Okay, so we're starting Unit 5, and this is slide 1. We're talking about comparing two cell phone plans. So a cell phone company offers an economy plan and a gold plan. The economy plan offers 300 free minutes for a flat fee of $20. If your usage exceeds 300 minutes, you pay 50 cents for each minute. The gold plan also offers 300 free minutes, but for a flat fee of $30. If your usage exceeds 300 minutes, you pay 30 cents for each minute. So, which plan do you think will save you money? Go ahead and type an answer into the box. This is totally just your opinion. Don't feel like you have to do any major calculations here. Just if you actually were out at like Verizon or Sprint or wherever, and you were trying to figure out what plan you needed, which one would you pick? Go ahead and submit that. You're all mathematicians right now, so when you type stuff on your screen, you don't come up as your own name. You come up as your mathematician name. Nice. I like what I'm seeing here. A lot of people. So it all depends on how many minutes you think you're going to use, right? So some of you, if you're spending tons of time on your phone, 300 minutes might not be enough. Like you might want to go with the plan that's going to give you the cheaper per minute, right? Others, if you don't spend a whole lot of time on your phone, or you don't spend 300 minutes, which 300 minutes, 60 minutes in an hour. 300 minutes is 5 hours. So some of you could burn that in like a day, I'm sure. But, you know, some of you might not. So maybe you want the economy plan. So nice. I'm seeing all of your replies. I'm going to say, let's see, what do I want to do? I would prefer the gold plan because I spend way more than 300 minutes on my phone. Okay, and you'd hit submit, and my response is right up there with everybody else's. Okay, very cool. Yeah, good, that's right. And if so, good, one son says that they would rather pay the money right up front. Good, excellent. Okay, move to slide 2. And then once we're all on slide 2, we're going to take a look at this and look at it from like a graphic point of view. All right. Okay. So once you have that, move to slide 2. Alrighty, so the real question is, how many minutes would you have to talk before you begin saving money with the gold plan? Well, we're going to put this in y equals mx plus b form, which you've been studying this in Unit 4, so y'all should be like experts at this. The slope is m, which is the cost per minute, and the y-intercept is the flat fee, like what you pay at the very beginning. So the economy plan charges 50 cents per minute with a flat fee of 20 bucks. Write the equation for the economy plan below. So let's see how that's going to work. You know it has to be y equals mx plus b. So we start out with y equals. Now, it said the slope is the cost per minute. That's the number that you put in for the m. So the cost per minute for the economy plan is 50 cents, 50 cents a minute. So you're going to put 0.50x plus the y-intercept is the flat fee. So no matter if you, like, even if you don't use your phone at all, they're still going to charge you that flat fee. That's like real life. So that's 20 bucks for this plan. So you're going to put plus 20. And y'all should come up with a real nice line. Make sure you put y equals so that you get the line. And so that line that you're seeing being graphed on your screen, that represents the money that you're going to spend on your cell phone bill the more minutes you talk. So like right here at zero minutes, you're still spending, they're still charging you 20 bucks. So that's the 20 is how much money you spend. If you talk 20 minutes, then you are being charged $30, okay? 40, roughly 40 minutes. I wasn't right out. There you go. 40 minutes, they're charging you $40 and so on. And it keeps going up higher and higher and higher. I think, nope, my little screen won't go any farther, but, oh, I'm sorry. This is after the first 300 minutes. I apologize for that. They're going to give you 300 minutes with that flat fee, 20 minutes over that. Okay, so I'm sorry, 0 minutes over 300 is going to be 20 bucks. If you talk 20 minutes over 300, so 320 minutes, then they're going to charge you 30 bucks. So let's just remember that they are giving you 300 minutes right off the bat before they start charging you per minute. Okay, so anyway, a lot of you have moved on to the gold plan, which is what I need to do too. The gold plan charges 30 cents per minute with a flat fee of $30. So Y equals, the cost per minute is the slope. So you put 0.30 and then X, and then a flat fee of $30. So plus 30 bucks. So the flat fee is a little bit more, $10 more, but the cost per minute after you talk or use 300 minutes is less. So notice that at the beginning here, they're charging you more, like you got to pay $30 at the very beginning. But over time, the slope is not as steep. So actually, after you pass this little point where they intersect each other, it's actually cheaper for you to be on the gold plan. See how the blue line started to become below the red line? So that's why this is going to be interesting for us, because now this is a system of equations. That's why we're studying this. You have two lines, not just one line that you're looking at. And so we're trying to figure out where those lines intersect each other, and when, for this problem, when the gold plan is actually the better deal. Okay, make sure you hit submit so you get credit for that screen. It looks like to me the point of intersection between these two lines is at 50,45. So what does that mean? That means that after you use your phone for 350 minutes, if you plan on using your phone for more than 350 minutes, you are better off using the gold plan, because it's going to be cheaper for you to use your phone. Okay, it's going to be less money. All those Y values that you see as I'm sliding down that blue line are how much it costs you on the gold plan. On the red plan, those Y values are bigger, so it would cost you more money. Okay, anyway, let's move to slide 3. All right, so we kind of just talked about this already. Now we're going to actually put it into the slide. After how many minutes would both plans be the same cost? So they are the same cost when they intersect each other, because that means they share a point. So at the beginning here, they're definitely not the same cost. Here, they're not the same cost. Here, they're not the same cost. And then when we get right to that spot right there, that 50,45, that's when those two lines both charge $45 for their monthly bill. So after how many minutes? It's going to be 345, okay? Don't forget that we got 300 minutes right off the bat. I guess I can't put the whole word, can I? So remember, we get 300 minutes to start with. Okay, it's okay if the little triangle comes up there. Good. What is that cost? How much is it going to cost us? Well, that is going to be the y value. After, oh, I'm sorry. Goodness, I put the wrong thing. 350 minutes. Sorry, guys. There we go. After 350 minutes, it's going to cost $45. Sorry about that. I got those mixed. So let's make sure that we make that adjustment. The x value is the minutes. So since it's 50, 45, we want it to be 350 minutes. And the y value is the cost, okay, which is 45. Explain how you found this solution. The cost is the same where the graphs intersect. This is where they share the same point. Okay? And you don't have to type exactly what I type. You can absolutely type it in your own words, whatever you feel explains it best. Yeah, good. Yeah, exactly. Where they meet. That's perfect. Very good. This one up here, it looks like it doesn't like my my typing, huh? Guess I'm gonna have to get rid of that little reminder there. There. Now it'll let me submit. Desmos is picky today. Okay. Awesome.
Good morning. At this time, we're going to get stickers rolling. We need all students, last name E. Please report to the auditorium. All students with last name E. Thank you.
We are doing pictures all week this week at the high school. So if you're here in class, they'll call your last name and you'll go down to the auditorium. Those of you at home, if you want to come in and get your picture taken for the yearbook, which I hope you do, you need to sign up for a time slot in the afternoon and you can come real quick. It's super fast. It takes literally like 3 minutes. You come in, you go into the side door of the auditorium, they take your picture, and then you're back out the door and in the car. Your parents don't even come in with you, like you just come. If you're able to come in and get your picture taken, that would be awesome. So that way we can have everybody's picture in the yearbook. So that's what's going on this week at school. That's why we're probably gonna hear announcements like every 5 minutes. Also, we're doing fire drills all week at school. Yay. Everybody in class today looks absolutely thrilled about this. They are happening every single day this week at 1 o'clock. So it'll be during your 4th block class. If you want to participate at home at 1 o'clock, set your phone alarm and walk outside of your house for a couple of minutes and then there you go. You'll have done the fire drill with us. So, okay, enough of that, right? Okay, so we're on to the next slide. Slide 4. All right, so this is called a system of equations. It's more than one equation with the same variables. One easy way to solve a system of equations is to graph each equation and find the slope, the y-intercept, and then where they intersect each other. That is what you are doing for this entire unit, you guys, every day. It's gonna be such a sweet test grade next week when you take the test, because that's all you're doing, okay? So, let's see here. So this is what we put in, and on the previous screen, we did 350 minutes, and that would cost $45. Using the same calculator, you could put 350 minutes in for X into each equation and see if you get $45 for each bill. So this algebraically, so if I go back to the other slide, the first slide where we had our equations. So 0.50x plus 20 and 0.30x plus 30. What does that mean algebraically? So algebraically would be if we were going to do this all by hand without Desmos, this answer, or this solution, I should say, is where the two equations equal each other. So you might be wondering, is she going to make us do this algebraically? And the answer is no, we're not going to do this algebraically. You might be heartbroken over that, but no, I'm not going to make you do this algebraically. But this is what it would look like. It would be 0.5x plus 20 equals, what's the other one? 0.3x plus 30. That would be what you would do algebraically. You'd set them equal to each other. Now, y'all, I know you could do this because you did harder problems than this back when we studied solving equations. But you would have to get the x's over on one side and the numbers on the other side, and then you would solve. So if I were to do that right now, I'll do it on paper so that way you can see it and you don't have to type all this. I just want to show you the algebra behind all of this stuff that Desmos is doing for us. It would be 0.5 or 0.50x plus 20 equals 0.3x, 0.30x is the same thing, plus 30. So I would subtract 0.3x from both sides. Like I said before, this is nothing new. Y'all can do this. So this would be 0.2x plus 20 equals 30. And then I would subtract 20 from both sides like that. Those would go, this would be 0.2x equals 30 minus 20 is 10. And then I would divide by 0.2, which would be, and see if we use the calculator for that, which I think I have a little calculator right here. That's convenient. So I would do 10 divided by 0.2, and I would get 50. So x equals 50. So that's where the 50 comes from. Remember up here, we had, it was 350 minutes. So this would be x equals 50 plus the 300 minutes to start with gives you an x of 350 minutes. Okay? And then if you wanted to figure out the y value, you could plug 350 in up here for one of these x values and it would give you the cost. So that's the algebra that would need to be done to solve all these. But our unit is on graphing. Unit 5 is all about graphing, so that's why we're not doing the algebra for this. We're just going to do the Desmos graphs. Okay, move on to slide number 5. Okay. Good, it looks like a lot of you have thought about this. All right, so almost everybody's there. Okay, so once you get to slide 5, you're given a system. And the reason it's called a system is just because you have more than one graph. Okay, you have 2 graphs. And you'll never have more than 2 graphs in Algebra 1. If you go on to like Algebra 2 or AFDA, you could have like 3 graphs, but we're just doing 2 right now. So you need to figure out the solution to the system. So the solution is where the graphs intersect. So if you go on your graph and click on that spot, it will give you the point. In the box, enter the x value of that solution. I'm not going to click on mine yet. I'm going to wait for you guys to, and then we'll check. Okay. Remember, when you submit You are submitting as your mathematician. It's not actually your name. So don't be afraid to submit. Give it a guess. All right, good, nice. Nice, Maria, Mary Ellen, Isaac, awesome. So when you click right there, the solution is 4,7. So the X value would be 4. Okay, good, and it tells you you're correct. Isn't that sweet? So if your solution didn't work, correct it. If it did, click next. I think we're good. It does work. If you put something else in there, let's say if I put 5, see how you get 2 different numbers here? That means that's not the right answer. So that's when we put 4, you both get 7. So that means we are correct. Hit submit, and let's go to the next slide. All right, now this one. You have a system. We need to find the solution. Type the X value, only the X value of that solution. Yeah, look, it's going to be 1. So you would type a 1, and notice it plugs it into the equations for you. So you get, when you get the same answer for both equations, you know you did it right. Very good. Looks good, guys. I see your answers are looking good. Move on to the next slide. And find the solution again. Nice. Excellent. Easy, right? Good. So just make sure you're putting the X value in. Don't put the whole point, okay? They're not asking for the whole point. Sometimes you will have to type the whole point, but these directions just are asking for the X value. So that's why we're just putting the 3. And good. Move on to the next slide. So click there. Okay. Make sure you put an answer in there. So you're going to solve this graphically. So they're not just asking for the X value for this one. We can write the entire thing. So 4,3. Okay. That's all you need to do. It is not plugging it in for you. So you would have to use your calculator to see if it works. We have the graphs. We can see that that's where they intersect. Okay. And then just hit submit after you type the point. All right, good. Once you have that, move to slide 9. All right, so for slide 9, you are finding where the graphs intersect. Put the X and the Y, yeah, write it as a point. For these, notice in these directions, it's not just saying type the X value, so make sure you type like the entire point. So to me, it looks like it's at 3, -2. So 3, -2 is your answer. Okay, so 3, -2. At the beginning, they were only asking us for the X. Now we need to type the entire thing. Good. Hit submit. And move to the next slide. Make sure you're putting the parentheses.
At this time, can we please have all students, last name F, please report to the auditorium. All students with
Okay, good. Maria, make sure that you are typing yours as a point with parentheses around it, so that way you get full credit. So that needs to be 6, looks like 6, 0. So 6, 0, like that. And hit submit. This is what you're going to do for homework. So should be a nice easy assignment. Okay, now check this out. Everyone, once you are done, and I'll give you like a little bit of time, move to slide 11, because this one is interesting. So sometimes lines are not always like, they don't always behave the way we want them to get our solutions. Sometimes the answer is no solution, okay? So on your screen, you can manipulate these lines however you want to. That's why I love Desmos so much. So you can move this around, you can do, I mean, you can do like anything. You can move the purple ones if you want to. You can do whatever you want. So on this one over here on the left-hand side of your screen, make those lines be so that there is no solution. What would they look like if there was no solution? Go ahead and do that, and I'll take a look at what you come up with. There's lots of different ways you could figure this out. Now, you have to think about them though. Be careful, because they're lines, right? So technically they go on forever. So just because they are not touching in your little graph box, make sure that they're never gonna touch. Like, make sure that they are drawn so that they would never touch, no matter how big a graph paper we had or screen that we had. So how would we do that? I'm seeing a lot of good answers. Nice job. Nice job. Concha, Ernst, Maria, Mary Ellen, Isaac. Nice job. Very good. All right, so you would, let's see, this is, I'll just do it mine. I kind of would like to move this away. Can I like move this away a little bit? Oh, that one's got a solution. I don't want it to have a solution. There we go, like that. So right now, my lines don't have a solution. And so those are from last unit. Those have the same slope. So those are parallel. So if you ever have a graph where you have parallel lines, the answer is going to be no solution. You are going to have a couple of those on your homework tonight, so don't be surprised. If the lines end up being parallel, it's no solution. Now, the one on the right, sometimes your graphs come out and you have like an infinite number of solutions. Infinite means like you have like tons and tons, like never-ending solutions. So how would you make your graphs have an unending number of solutions? What would you do? So manipulate those lines over on the right-hand side of your graph to have an infinite number of solutions. How would you move these things? Good, Isaac. Isaac Newton. Should have figured that Isaac Newton would have got this like immediately. Nice job. Very good. Keep moving them around, guys. How would you have those graphs so that there would be an infinite number of solutions? What would that look like? How would we move these around? Can't be parallel. It can't look like that because that's still just one solution. What would we have to do? Looks like somebody made theirs like flat like that. What would you have to do with the other line in order to have an infinite number of solutions. Well, if the solutions are where the graphs touch each other, you'd have to make your graphs so that they touch each other everywhere. So how would you make your graphs touch each other everywhere? And it doesn't have to be flat. It can be any way you want. It can be slanted. How would we make that so they touch everywhere? Let's see, maybe if we move this one and we move this and we move this. Ah, there we go. Does everybody see that? It looks like one line, but there's actually a line on top of another line completely. And so that's what it looks like on a graph when you have an infinite number of solutions. Oh, over here, this is telling me that my line must not be perfect. Is my slope off? Let's see. 5, 10. Let's go here. Nope, I don't want to do that. I want to go here. Nope. Ah, there we go. You know you've done it right when it says great job up above of your little graph. The parallel one's a little difficult because you got to make sure that they have the exact same slope for both of those. All right, so for your homework, you're going to have a couple of problems where the answer is infinite number of solutions. And so when you do those graphs, it's just going to look like one line. So just so you know that, that's what that looks like. So we could have one solution, no solutions, or an infinite number of solutions. That's the choices for this unit. Alrighty, so let's move up to slide 12. We're almost done. In slide 12, this just gives you like a set of notes. There's nothing you have to do on this slide. If you want to take a screenshot of it, just to like have so that when you're working on your homework and stuff, you have something to look back on without having to go back into Desmos, you can. It's got everything that we just talked about all like in one slide. So, okay, let's move on to slide 13. And we're going to end on a word problem, of course, right? Because we got to make sure that this actually makes sense in real life. And what better way to do this but to talk about pizza, especially at like 8:30 in the morning. So I love cold pizza personally. So, all right, here we go. A large pizza at Palancio's Pizzeria costs $6.80 plus 90 cents for each topping. The cost of a large cheese pizza at Guido's Pizza is $7.30 plus 65 cents for each topping. Write an equation for the cost of a large pizza at Palancio's Pizzeria. Okay, well, this is just like the cell phone plan, right? You're getting a pizza and they're going to charge you a certain amount no matter what, just for the actual, like for the crust, basically. And then they're going to charge you extra on toppings. So start with y equals, okay? And just like the cell phone plan, the slope is going to be the money for each topping. So every time you ask for another topping, they're going to charge you another 90 cents at Palancio's. So that is your slope of your line, okay? And then on top of that, there's like just the regular charge that they charge you for a basic pizza. So plus 6.80. And then if you put y equals, make sure you do that, and then it'll graph it for you. So that line that you see on your screen, that represents how much it's going to cost for a pizza, depending on how many toppings you order. So if you order 0 toppings, it's only going to cost you $6.80. If you order 4 toppings, I'd slide way over here, 4, if I can get right on 4. If you order 4 toppings, it's going to cost you $10.40 for that pizza, which is a pretty good deal. Okay. All right. Now we need to write an equation for the cost of a large pizza at Guido's. Well, same idea. Y equals, the toppings are the slope because every time you get a new topping, they tack on more money. So 0.65x plus the basic fee, the basic charge for a pizza with no toppings. So 0.65x plus $7.30. So now we need to solve the system of equations and use the embedded calculator to check your solution. Explain what this solution means in words. So this is a system. It's called a system because you have 2 lines on your screen. The solution is where the lines cross each other, where they intersect. So let's see, I guess we'll just, I'm gonna assume it's like right about here. Somewhere in here. Yeah, I think it's right about there. If I can get on both lines, hopefully, yeah, there we go. Oh, it won't stay lit up for me. But it looks like those pizzeria shops are gonna charge you the same amount of money for a pizza if you have X being 2 and Y being 8.6. So now we need to describe what that actually means.
May I have your attention, please, all students, last name G, please report to the auditorium. All students with the last name G, please report to the auditorium.
So what does this mean? Well, the 2 is down here. It's the X coordinate. That's the number of toppings. And the 8.6 is the Y coordinate. That's the cost. So this means that you can order 2 toppings at both pizzerias, or both pizza places, I'll just say that, for the same cost, which would be $8.60. Okay. Go ahead and type that however you want to say that in your own words and submit it. So both pizza places end up charging you $8.60 for 2 toppings. After that, let's see here, was the red one, the red one was Guido's, right? Looks like Guido's ends up being cheaper because the line is lower. That means the cost is less. So, you know, if you were trying to pick between 2 different places and you're on a budget, I would go with Guido's because it's going to cost you less money. Okay. In the beginning, it looks like Palancio's would cost less money because the green line is below. So if you don't want any toppings or you only want 1 topping, I would go with Palancio's because that's going to be cheaper because it's below. But after that, if you want more than 2 toppings, Palancio's is actually more expensive, so I would go with Guido's, okay? Little things like that, little decisions that you guys make, or when you're adults, you're gonna make all the time. You don't realize that it can be actually figured out with a little algebra. All right, let's look at 14. Mrs. Travis wants to have a clown deliver balloons to her secretary's office. Clowns Are Fun charges $1.25 per balloon and $6 for delivery. Singing Balloons charges $2.25 per balloon and has a $2 delivery. So we need to write equations for both. So Y equals, always start with that. This time, the slope is going to be the charge per balloon, okay? Because that is what is changing. The more balloons you want, the more money it's going to cost you. So that's going to be $1.25x plus the $6 delivery. So you could have 10 balloons It would be 10 times $1.25 plus $6 to deliver them. Or you could just pick one balloon, 1 times $1.25 plus the $6 delivery. All right. The second equation is going to be for singing balloons. The slope, once again, is the charge per balloon. So 2.25x. They only charge $2 to deliver. So plus 2. Go ahead and solve the system of equations. You can use the calculator to check if you want to, but we do have a very nice graph. So I would say that you don't have to use that calculator to check for these. And then in your own words, explain to me what that solution means. And if you need to go back to the pizza problem for help, you can, because it's very similar. Don't forget to write your explanation in words. Don't just tell me the solution. Also tell me why, or what does that solution represent? What does it mean in this problem? Alrighty, good. I'm seeing some good answers. Nice job, everybody. Yeah, good. So if you click on this little spot right here, it's 411, which I am seeing on all y'all's responses, and that is correct. And what does that mean? So I'm going to steal an answer that I see, and that 411 means it would be the same amount of money for 4 balloons. How can we say this, like, to finish it off so it's a nice sentence? It would be the same amount of money for 4 balloons if clowns, let's say, we'll just say from each company. That way we don't have to like write too much. And the cost would be $11. So if you order 4 balloons from Clowns Are Fun, it's going to cost you $11. And if you did 4 balloons from Singing Balloons, they're also going to cost $11. Now, if you want more than 4 balloons, I would go with the green line because it's lower. It would cost you less. So that would be Clowns Are Fun. So if you wanted more than 4 balloons, you want to go with the line that's lower. If you don't want more than 4 balloons, like if you wanted less than 4 balloons, maybe 3 balloons or 2 balloons, then Singing Balloons is going to be the better deal for you. That's going to be cheaper because that red line is below the green line. So if you're ever thinking of like owning your own business and you have to cut costs so that you can make more profit, you have to look at graphs like this. What's trending? What's gonna make the most money for you? All right, go ahead and hit submit, and we're on to the last slide. Last slide. Job number 1, you make $600 per week. Job 2, you make $400 a week plus $1,000 signing bonus. So $1,000 signing bonus is that they give you that's what they give you right off the bat when you take the job. So you get $1,000 right away, but you only make $400 a week. Job 3, you make $800 per week, but you have to pay, you have to pay $1,000 to get certification. So those of you that might want to go and take computer classes like Hornet Tech and all that good stuff, you have to pay a fee to take the test, like Net Plus and all of those different certifications, you have to pay a fee. So this one would be, you'd have to pay $1,000 for this fee. So we need to write an equation for each one. Oh, it looks like we are going to have 3 equations. Well, this must be a challenge. We don't have to, you won't have to do this for homework, but we can figure this out, right? So job number 1, you make $600 a week. So Y equals, well, the only thing we have to work with is 600. That is going to be your slope. Every week that goes by, you get another $600. So if you work that job for 1 week, it'd be 600 times 1, which is, you'd make 600 bucks. If you work that job for 2 weeks, it would be 600 times 2, and so forth. So that's why the X has to go behind the 600. There's your graph.
At this time, we need freshman students with last name H. Please report to the auditorium. Freshman students only, last name beginning with H. Please report to the auditorium.
All right, so for job number 2, you are going to make $400 a week, plus you get a $1,000 signing bonus. What would that be? Yep. All righty, so this is going to be $400 a week will be 400x, plus you get that $1,000 right off the bat, so you're going to put plus 1,000. Last one, write an equation for job number 3. So Y equals, now we're making $800 a week. That's really sweet. So it'd be 800x, but at the very beginning, you have to pay $1,000. So that means that's money coming out of your pocket. So that means a minus because you have to pay it. If it were plus, that would mean they'd be giving you the money like the first job, or I'm sorry, the second job. But we got to pay this, so that's a minus. So 1,000 like that. So now you have 3 lines. You need to solve the system of equations and use the embedded calculator if you want to check. Explain what this solution means in words. Go ahead and find the solution, and don't forget to type your explanation. All right, nice job. I'm seeing some great answers. Don't forget to put the actual solution, right? So the solution to all 3 of those would be where they all touch each other. Looks like it's going to be at 5, 3,000. 5, 3,000. So what does that mean? That means after working 5 weeks, all 3 jobs pay the same amount, which would be 3,000, oops, not 2,000, $3,000. Now, some of you are making some excellent observations though. Awesome observations, nice job. So some of you are saying blue is, you're making the most money with blue. Absolutely, you're right. You're making the most money with blue, but you gotta stick with the blue job for at least 5 weeks. Notice in the first 5 weeks, blue is the lowest. So like you actually don't have as much money as the people working the green job and the red job. It looks like the red job is actually the one to have at the beginning because they give you that signing bonus. But Over time, if you stick with the blue job, if you pay that $1,000 to get certified, you actually end up making way more money than the people with the green or the red job. So pretty interesting how that works out. Okay, nice job. Nice job, everybody. All right, so that rounds out. Go ahead and submit that once you have it in your own words, however you want to explain that in your own words. The basic idea is that they all pay the same amount of money at 5 weeks because that's where they all intersect. But other than that, that is today's instruction. So I'm going to stop the recording